The ground trembles under the weight of an agile yet heavy stride, a sound that cuts through the thick, pine-scented air of the late Jurassic 150 million years ago. From the shadows of giant ferns, a ghost-like figure lunges with terrifying speed, its eyes locked onto a target with cold, predatory intent. It does not possess the sheer, earth-shaking mass of a Tyrannosaurus rex, but it has the grace of a sprinter and jaws that function like a lethal battle axe. This is Allosaurus, the undisputed apex hunter of its era. While the long-necked giants ruled the horizons through size, Allosaurus ruled through brutality, tactical precision, and a specialized hunting style that made it the most successful predator in the history of the American West. The history of Allosaurus is inextricably linked to the most chaotic and competitive era in the history of paleontology, the Bone Wars. In the late 19th century, two legendary rivals, Othniel Charles Marsh and Edward Drinker Cope, engaged in a frantic race to name every fossil found in the American West. This was an age of discovery driven by obsession, where specimens were sometimes dynamited out of the ground to prevent them from falling into rival hands. It was amidst this scientific battlefield that the name Allosaurus was first established in 1877. The name is derived from the Greek words meaning different lizard. Marsh chose this name because the vertebrae of the animal were fundamentally unlike any dinosaur known at the time. They possessed a lightweight structure and were filled with air sacs, a process known as pneumatization. This reduced the animal's weight without compromising the structural integrity of the skeleton. This discovery proved that large theropods were not sluggish monsters, but were biologically optimized for rapid movement and efficiency. The Cleveland Lloyd Dinosaur Quarry in Utah later became the epicenter of our understanding of this species. This site remains a paleontological mystery, containing thousands of bones from dozens of individuals of various ages. Because of this massive sample size, Allosaurus has become the most thoroughly understood large theropod in the fossil record. Every rib and tooth recovered from this site tells a story of an animal that was the benchmark of predatory success for millions of years. To comprehend the dominance of Allosaurus, one must dissect its biomechanical architecture. An average adult measured between 8 and 9 meters in length, though exceptional specimens suggest some individuals reached 12 meters. It stood approximately 2.5 meters tall at the hip and weighed between 2 and 3 tons. While it lacked the crushing bulk of the later T-Rex, Allosaurus was built for a style of engagement that favored agility and repeated strikes. Its hind limbs were a marvel of muscle and bone. They featured massive thigh muscles and a digitigrade stance, meaning it walked on its toes, which allowed for sudden bursts of acceleration. This was an animal designed to close distances quickly. Unlike the tyrannosaurids that evolved tiny arms, Allosaurus possessed long, muscular forelimbs equipped with 3 functional fingers. Each finger ended in a recurved, razor-sharp claw that could reach 15 centimeters in length. These claws acted as biological meat hooks, allowing the predator to grapple with and restrain struggling prey as it prepared the lethal blow with its jaws. The tail of the Allosaurus was exceptionally long and served as a stiffened counterbalance. By moving the tail in opposition to the torso, the animal could maintain balance during high-speed chases or sharp turns in dense forest environments. Furthermore, the presence of gastralia protected the internal organs and provided additional surface area for muscle attachment. Every aspect of this anatomy was a specialized adaptation for a single purpose: catching and dismantling the fastest and largest creatures of the Jurassic world. The most terrifying and scientifically debated feature of the Allosaurus is its skull. For decades, researchers were puzzled when computer simulations revealed that Allosaurus had a surprisingly weak bite force. In fact, Its bite was less powerful than that of a modern lion, and represented only a tiny fraction of the power found in T-Rex. However, a landmark study utilizing finite element analysis revealed a shocking mechanical secret that changed our perception of this predator. While its jaw muscles were not built for bone crushing, the skull of Allosaurus was incredibly reinforced to handle massive vertical impact forces. The animal possessed a unique neck joint that allowed for extreme downward mobility and power. This led to the proposal of the Hatchet-Bite theory. Instead of biting and holding on until a victim died, Allosaurus would open its jaws to a staggering angle of nearly 79 degrees. It would then lunge its entire head downward with the force of its neck muscles, using its upper jaw as a biological battle axe to strike deep into the soft tissues of the prey. Its teeth were smaller and narrower than the teeth of a tyrannosaur, but they were razor-sharp and featured fine serrations on both edges. These teeth functioned like saws, creating massive wounds that would not easily close. By delivering a series of rapid, high-impact chops, Allosaurus could induce massive blood loss and shock in its victims. This tactic allowed it to weaken gargantuan prey without the risk of being injured by the prey's defensive movements. It was a strategy of precision and persistence rather than brute force. The Morrison Formation, the ancient home of Allosaurus, was one of the most productive environments in the history of life. It was a vast landscape of river valleys and floodplains that supported the greatest concentration of sauropod giants the world has ever seen. Allosaurus shared its world with behemoths like Apatosaurus, Diplodocus, and the towering Brachiosaurus. To bring down these titans, which weighed dozens of tons, Allosaurus had to be a master of risk management. Direct fossil evidence has confirmed a brutal arms race between Allosaurus and the armored Stegosaurus. One specific Allosaurus tail vertebra was discovered with a circular puncture wound that matches the size and shape of a Stegosaurus tail spike. This injury shows that the predator was struck from behind with enough force to penetrate bone. In a spectacular reversal, a Stegosaurus neck plate was found with a U-shaped bite mark that matches the jaw of an Allosaurus perfectly. These fossils represent the scars of a prehistoric battlefield, where every defensive plate was a response to an offensive claw. Allosaurus was also a highly versatile opportunist. Its brain possessed exceptional olfactory bulbs, giving it a sense of smell that could detect the scent of a carcass from several miles away. This allowed it to maintain its energy levels during the harsh, dry seasons when living prey became scarce and the great sauropod herds migrated. It was the essential regulator of the Jurassic ecosystem, culling the weak and ensuring the flow of nutrients through the environment as both an apex hunter and a dominant scavenger. The most famous individual of this species is Big Al, a nearly complete subadult specimen found in Wyoming in 1991. Big Al is more than just a museum attraction. He is a biological record of a violent and tragic life. By performing a detailed analysis of his bones, scientists counted a staggering 19 different injuries and bone pathologies that afflicted the animal during its short life. Big Al suffered from multiple broken ribs, severe infections in his feet, and various impact fractures along his spine. One particular infection in his right toe was so debilitating that it likely prevented him from hunting properly for a significant portion of his life. This infection showed signs of chronic inflammation, suggesting the animal was in constant pain. The sheer number of injuries across the Allosaurus fossil record suggests that their lives were incredibly dangerous. Attacking armored dinosaurs led to frequent accidents. However, the healing found on these bones proves that Allosaurus was a resilient survivor, capable of recovering from wounds that would have immediately killed most other animals. Allosaurus was not the only giant predator roaming the Morrison floodplains. It shared its territory with the horned Ceratosaurus and the massive Torvosaurus. The coexistence of three giant theropods in a single ecosystem is a classic example of niche partitioning, a biological strategy where species utilize different resources to avoid direct conflict. Torvosaurus was significantly larger and more heavily built than Allosaurus, likely acting as the heavyweight of the Jurassic that focused on the largest prey. Ceratosaurus, with its distinct blade-like teeth, may have preferred different prey items or perhaps occupied more densely forested environments or river edges. Allosaurus, however, was the most numerous by an overwhelming margin. Fossil records show that Allosaurus outnumbered its rivals by nearly 10-to-1 in some areas, suggesting it was the most adaptable generalist of the group. It could thrive in river valleys and open floodplains, allowing it to maintain its status as the dominant predator of the continent for millions of years. One of the greatest mysteries is whether Allosaurus was a social animal that hunted in organized packs. The massive accumulation of individuals at sites like Cleveland Lloyd was once thought to be proof of a family group. Modern interpretations suggest these sites were natural predator traps. A few herbivores would get stuck in the mud of a drying lake bed, and their distress calls would attract a single Allosaurus. When that predator also became stuck, its struggles would attract more predators, creating a lethal cycle of death that preserved a cross-section of the local population. While organized pack hunting remains a subject of debate, we know for certain that Allosaurus engaged in cannibalism. At the Mygat Moor Quarry, the bones of Allosaurus were found bearing the bite marks of their own species. These marks were found on bones with very little meat, such as the ribs, suggesting desperate scavenging during times of catastrophic drought. In the unforgiving world of the Jurassic, there was no room for empathy. An injured rival was simply another source of protein, a ruthless strategy of opportunism that ensured the survival of the strongest. To truly understand the lion of the Jurassic, we must look inside its skull. Advanced CT scans of Allosaurus brain cases have revealed a sophisticated nervous system. The brain was relatively large for a theropod of its size, with the structure more closely resembling that of a crocodile than a bird. This indicates a highly effective level of intelligence focused on sensory processing. The inner ear of Allosaurus shows that it was sensitive to low-frequency sounds, which would have been perfect for hearing the deep thuds of walking sauropods from miles away. Its eyes were large and positioned slightly toward the side, providing a wide field of vision that was ideal for scanning the open plains for movement. While it lacked the overlapping vision of a Tyrannosaurus rex, its wide-angle view made it a master of situational awareness. These senses worked in perfect harmony with its physical prowess, allowing it to navigate the complex environment of the Morrison Formation with the confidence of a true apex predator. The life of an Allosaurus was a race to reach maturity. By studying the growth rings inside the bones, paleontologists have determined that Allosaurus grew at a much faster rate than modern reptiles, more akin to the growth rates seen in large mammals. They likely reached full adult size by the age of 15, with a lifespan that rarely exceeded 30 years. A juvenile Allosaurus looked significantly different from an adult. Its legs were proportionally longer, and its body was much more slender, suggesting that young individuals were specialized sprinters that likely hunted small, fast-moving dinosaurs. As they aged, they became more robust and transitioned to hunting the larger herbivores of the region. This niche shifting during growth allowed Allosaurus to dominate the ecosystem at every stage of its life, effectively preventing other smaller predators from gaining a foothold in the environment. No discussion of the Allosauroid lineage is complete without mentioning the ultimate version of the design, Saurophaganax. Found in the late Jurassic rocks of Oklahoma, this animal was essentially a super Allosaurus. It reached lengths of 12 to 13 meters and was the only predator in the Jurassic that truly rivaled the T-Rex in size. Saurophaganax represents the final expression of the allosaurid body plan. It possessed even more specialized vertebrae and more robust forelimbs, making it the supreme ruler of the southern Morrison Formation. While it is rarer than Allosaurus, its existence proves that the different lizard blueprint was capable of scaling up to meet the demands of a world filled with 30-ton sauropods. It was the absolute pinnacle of the Allosaur dynasty, a titan that ruled the plains until the shifting continents changed the world forever. Allosaurus represents the zenith of the Allosauroidea lineage, a branch of the dinosaur family tree that flourished long before the tyrannosaurs achieved dominance. Its success was so profound that it paved the way for even larger descendants on other continents. The great Carcharodontosaurus of Africa and the massive Giganotosaurus of South America were the direct evolutionary results of the successful blueprint established by Allosaurus. At the end of the Jurassic period, a combination of shifting tectonic plates and changing global climates led to the collapse of the Allosaurus empire. The environment transitioned into the early Cretaceous, where different types of plants and herbivores required different hunting strategies. However, the place of Allosaurus in history is permanent. It proved that a predator did not need the strongest bite force or the most massive body to be a king. Through a combination of anatomical balance, a specialized axe-like attack, and incredible physical resilience, it carved its name into the stone as one of the most terrifying creatures to ever walk the earth. Allosaurus was more than just a monster from a textbook. It was a masterpiece of evolutionary engineering. From its unique hatchet-bite to its sprinter-like agility, it redefined the concept of an apex predator in the Jurassic period. The scars on Big Al's body are a reminder of the grueling yet magnificent life this different lizard led. If you want to continue this journey through time to decode the mysteries of lost giants and the silent assassins of the past, please consider subscribing to this channel. Your support is what drives us to keep bringing the echoes of extinction back to life for the modern world. What do you think about the Allosaurus's hunting strategy? Was the hatchet-bite actually more terrifying than the crushing power of a T-Rex? Let us know your thoughts in the comments below.